STKM6033 will present the topic of omega-3 production by fermentation of YL from fat batch to continuous. The introduction. Omega-3 fatty acid is a long-chain polyunsaturated fatty acid, LC-PUFA. Intake of LC-PUFA in diet normally EPA and DHA, but there is limitation due to overfishing and contamination. To overcome this, DuPont established a length-based long-term EPA source using YL metabolic engineering and produced either omega-3 or omega-6. The objective of the study is to provide a long-term source of EPA synthesis through fermentation metabolic engineered YL to design a two-stage continuous fermentation approach and compare to a standard fat batch process and to create dynamic model of EPA synthesis. The method this is normal method, fat batch fermentation. Start with seed culture, add initial fermentation medium, filter and ferment. And this is a two-stage fermentation. Step 1 is the production method. Start from day 0. The method is same like a fat batch, but the condition can refer table 2. And then follow is the step 2, which is the grow step. Started at day 3, and the method also same like a fat batch, but the condition can refer table 3. And the step 3 is the two continuous fermentation was started after 120 hours in stage 2 continually from stage 1 to stage 2 and pumping out to a storage tank. Collecting the product is after 42 days.
Next, the result. Table 4 shows result comparison between fat batch and two-stage continuous fermentation. The table shows that two-stage continuous fermentation improved the final EPA productivity by 80% with very similar EPA titer in biomass and EPA conversion yield. It also improved EPA concentration by 40%. Next, the figure shows experimental results and results predicted by model of EPA production by two-stage continuous fermentation. The fermentation is accompanied by continuous evolution of the Yarrowia lipolytica Z7334 strain. Figure C shows that the strain produced an increasing amount of lipid in the biomass, and figure G shows that the strain produced a decreasing amount of byproduct. Next, the discussion. The two-stage continuous fermentation provides a sustainable source of EPA production compared to usual source of EPA, which comes from fish oil. The fermentation affects the result by improving the EPA production and reducing byproduct. By reducing byproduct formation, more carbon flow was introduced into the lipid synthesis pathway, which improved EPA production even further. As a conclusion, the two-stage continuous fermentation process boosts EPA production while keeping EPA titer and conversion yield constant. It also has the potential to be a good source for omega-3 production, as well as a wide range of different fermentation processes characterized by non-growth or partially growth associated kinetics.